I guess possibly other countries too, for listening in. And thanks to any of you guys who are going to be listening or watching this on our YouTube channel down the road. Kind of weird to make an introduction to people who are not yet listening, but we'll get that out of the way. So today's topic, I wanted to talk about some new products we've got starting in Q4, either things that are currently available for sale or things that we will have part numbers and pricing on any minute now. There's a lot of items that kind of finally got launched last week at SPI that we're really excited about. And that's really crazy to say last week at SPI, because it feels like it's been about 30 days since SPI. So I don't know if you guys are having the same effect, but time does not seem to be linear anytime you're talking about conferences and trade shows. All right, well, let's get kicked off. What are we going to talk about today? You guys know I love to cover the agenda. Before we jump into the nitty-gritty nuts and bolts of which new products and what are they and how do they work, just talk real quickly about some of the drivers. These drivers are dynamic, and at any given time, we may be looking at kind of different forces that are guiding new product development and new product launches out in the market. Specifically behind some of these we'll be talking about today, NEC 2017, California Rule 21 Phase 2, that's a bit of a mouthful, and then the new products we'll be talking about in Q4, inverters, modules, and racking. So what's new in the marketplace and what drives these things? Generally speaking, from the manufacturer perspective, a lot of us who've worked in manufacturing, tend to recognize the forces at play there, and the first one there is inertia. Simply put, if it's not broke, don't fix it. That has really never been the case in solar. It doesn't seem like. We're in an industry where products change rapidly. The product development cycle, so the time to bring products to market is, I've seen it as quick as 6 months, but typically we're looking at more like 1 to 2 years from what we call ideation to drop it on your feet launch. So in a market where it takes 1 to 2 years to bring products to market, we're looking at product life cycles that are 2 to 3 years. Looking at some of the most successful modules and inverters we've seen on the market, I'd say 3 is probably the limit. So think about that for a second, that it takes 2 years to get something to market. And after all that work, you've got 3 years to get it launched, get it mature, get it running and rolling out to customers and installed. And then you're looking at a phase out or obsolescence plan. So it's really an incredible aspect of our industry that I think goes underappreciated. Just, how hard it is to get these things to market, and then how little time you have to actually, make it work and make it profitable. I digress a little bit. So what drives new products? We talked about the dynamic of it's not broke, don't fix it. That's not the case in solar. There's always something to improve on. We're in a market where the unit economics of solar are really guided on the cost of grid energy, and we're always striving to achieve grid parity in more places or beat grid parity. So can we get the levelized cost of energy down to a point where it is an economic no-brainer for each and every American or Canadian, et cetera. In addition to that, things that are driving new products, compliance. So typically when we talk about that, we're talking about codes and standards, time savings. We've seen some great products that haven't taken off because they were harder to install, and we've seen some products out in the market that kind of make you scratch your head, but when you see how quick they are to be installed and how much labor they save, they become no-brainers. Cost savings, this is kind of obvious when we're looking at unit costs on cents per watt and fractions of cents per watt. Anything we can do to drive down bill of material cost is always seen positively by you guys, and the end result of having a more cost-effective system for homeowners is, I don't think that's lost on anyone. Yield improvements, this could be a couple things. When we talk about yield improvements, we're generally talking about kWh output. How do we get that? Well, it could be products that kind kind of widen your production window during the day, things that will make your system energize earlier and stay on longer. We're also talking about efficiency. So while that system is up and harvesting, harvesting more of those electrons back into your system or out onto the grid. The combination of production time and efficiency is going to generate more harvest. And then the last thing here is install versus retrofit. We're closing in rapidly on 2019, which is a very scary thought. And we're getting to a point in the industry where there's obviously an increasingly large, increasingly important installed base to try to market products to. We see this, we see this most prominently in the utility scale space, where some of these projects that were built, almost a decade ago, you're looking at new ways to get more harvest, get more energy out of that same, array or field. Some of the easiest ways to do that are inverter retrofits. Now, you don't see a lot of product in the market that is just a straight drop in comparison to the, in some cases, really odd-sized central inverters we had even as little as 4 years ago. You think about some of the inverters and the offerings from folks like Solectria and Satcon, those power ratings are just not available anymore. Furthermore, some of those string and central inverter options had some pretty peculiar string sizing. So I'm getting away from myself, but there's more and more products being brought to market now because they are more well suited to retrofits for some of these ground mounts and central inverter applications. And we'll speak to that a little bit later. Product categories: inverters, micros, optimizers, storage products, modules. These are, what I mean by that is these are new products that are driving innovation and a broadening of our portfolio in and of themselves. So as we get better technology around inverters, micros, optimizers, et cetera, that's leading us to drive better or more well-suited balance of system, modules, et cetera. All right, code changes. I wanted to spend a minute on this because this is behind some of the products we're seeing launched in Q4 and definitely some of the things we're seeing for early Q1. So the first one is the TIA, and I apologize, it's Friday morning. I have forgotten what that acronym means. I'm sure there's some of you guys out there that could remind me, but essentially an updated rider to the 2017 code, which will require module level rapid shutdown in impacted areas. If any of this is new or foreign to you, look up our YouTube channel. Aaron Liggett from our team did a great webinar earlier this year on code changes related to 2017. He speaks he speaks very pointedly to the module level rapid shutdown we're going to be seeing, as well as some of the other changes with respect to wire indicators, controlled circuits. I believe there's some stuff on arc fault in there. Check it out when you've got some time. The other thing that's going to be driving some of these technology changes, and this is going to be much more behind the scenes in terms of communication, but California Rule 21 Phase 2. So for those of you that recall, California Rule 21 Phase 1 was implemented, about this time last year. Phase 1 required inverters to be autonomous and to make autonomous decisions for grid support. So what we mean by that is when the inverter senses certain grid conditions like over or under frequency, over or under voltage, that there's autonomous, as close to instantaneous reactions as possible to help support the grid, either by curtailing, injecting active power, injecting reactive VARs, those kinds of things. Inverters had to be capable of making those decisions autonomously and very quickly. Phase 2, that's going to be effective February 2019, is going to require those inverters, any inverters installed past that point, to be two-way communication capable. What does that mean? The inverters will need to be able to speak to a grid operator. So it could be an ISO, it could be a utility, it could be, that's the scope of it today, but basically these inverters being capable of two-way communication Phase 3 that we'll see is really when we'll start to see some firmness on the standards for what kinds of commands are going to be issued to inverters. So very exciting times from a perspective of code changes and how this is going to drive a smarter grid. For your own edification, everything we carry right now will be, well, all of the grid interactive and grid connected string inverters and MLP that we carry will be Rule 21 Phase 2 compliant. There may be some specific questions on some of the product typically used in grid tie battery backup. If you've got questions on that, please reach out. We've got a slide at the end where we provide email addresses and phone numbers for you to get in touch with us. So that's code changes. Let's get into the fun part. What are we going to talk about? I'm going to lead off with SkyBox from Outback. It's a product we've been very excited about for a long time, and it's here. So we can talk definitively on what this product means, what it will do, when we'll have it available, etc. SMA Sunny Boy Storage got an update for you guys here. This is another product we've been eagerly awaiting, and promises to target a pretty tricky application that has not had a lot of good solutions over the past couple of years. Want to speak to the SMA Core 33 and Core 62 commercial inverters and some of the equipment that you'll need to make that rapid shutdown compliant, but excited for those as well. And then we'll finish up with NPeak, and I've got one final slide that didn't make the agenda here on just kind of all sorts of other things we've heard and some updates from SPI. So let's keep moving along here. SkyBox from Outback Power. So if you have had your head under a rock for the past year or so, or you've forgotten what is SkyBox, SkyBox is a fully grid interactive hybrid inverter. What we mean by hybrid inverter is that it functions essentially as both a PV inverter and a battery inverter. Hopefully these are terms that are understood by more than just me, but what we mean by PV inverter is this is an inverter that's going to harvest DC wattage from an array and invert directly to AC. A battery inverter typically has meant inverters that are capable of harvesting DC wattage from a DC bus, usually kind of post charge controller. The DC bus is going to be current from your charge controllers, current from your battery. A battery inverter is going to invert from that DC bus to AC. In typical, quote unquote, typical applications, you'd use a battery inverter with a charge controller. In AC coupling, you might pair a battery inverter with a PV inverter. A hybrid inverter, so obviously what we're looking at here from Outback, is capable of doing both in the same box. Other similar hybrid inverters out there are going to be the Solar Edge Storage product. We're starting to see some products from folks like Delta and Huawei being discussed and presented at SPI. Have yet to see any of those solutions hit the market. So for now, it's a pretty small universe in terms of capable hybrid inverters. SkyBox, of course, supports time of use and self-consumption applications and grid tie battery backup applications. The reason we typically refer to those two groups as different and unique is in a TOU or self-consumption application, you're not concerned with backup, so you typically wouldn't carve out backup loads or critical loads on a separate panel. A time of use or self-consumption machine is strictly there to maximize the amount of consumption without injecting power back onto the grid. So, and that's a topic we could spend hours on, but essentially you're not concerned with backup loads. In a time of use or self-consumption application, you're not going to have backup if and when you have a grid outage. In grid tie battery backup, you would. Obviously going to be compliant to Rule 21 and Hawaii or HECO Rule 14H. One of the big things we're excited about from SkyBox is its ability to work with a wide array of 48-volt battery systems, AGM, flooded, the lithium iron phosphate drop-in lead acid replacements. And we've got a roadmap to get to kind of full communication with some of the more popular NMC or other I'm thinking of the right way to say this, other chemistries involving cobalt. So we're looking at a roadmap where you'd be able to use SkyBox with LG Chem, and those two things would communicate directly with each other. So very excited for that. Talking about ratings and things, 5 kW continuous rating from PV or battery, a much improved wiring box load center. I don't have good images of it here, but if you've seen it at SPI or one of our road shows, and you have any experience with other grid tie battery backup or other hybrid equipment, it is a very easy to use wiring box load center. Plenty of room for breakers, plenty of room for fingers, and I think most of you guys with experience in Outback will find it a dramatic improvement over similar load centers. Applications, backup or self-consumption TOU. What we've got pictured here is a pretty typical, we think, backup slash TOU application. I use the slash in there because what we've typically seen in North American markets is you kind of have to throw up the backup capability there to win over time of use converts. What we mean by that is typically speaking, the value prop associated just with time of use or self-consumption isn't enough to get homeowners off the fence, and they're going to want backup capability. It's kind of like the if you give a mouse a cookie, if you give someone the option to do self-consumption or time of use, they're typically going to want to do backup as well. It's kind of one of those not common sense upsells, but I think you'd be hard pressed to find a lot of homeowners that would be willing to forego the backup capability just to achieve the economic savings around self-consumption or time of use. For those of you really familiar with Outback installations, you're going to look at this and say, okay, well, I'm missing either a charge controller or a PV inverter for AC coupling. No, you're not. The SkyBox product is intended to and designed to be more or less an all-in-one, with the exception of storage, obviously. But you're going to be able to harvest PV power directly in an inverter. It's going to be able to control and optimize battery storage, and of course, you're going to have exports for either your backup panel or straight back to your main panel. 600 volt string inputs, 1 MPPT channel. We're very excited about this product, and we think it's going to solve a lot of unique applications out there. Let's keep moving forward. The next one out here, another storage product, SMA Sunny Boy Storage. So there's a lot here that's been talked about for some time, and I think we kind of soft launched this product in Q2. We've been waiting on what you're going to see on the next slide for quite some time. I'll just revisit what we've talked about in the past with Sunny Boy Storage. So supports AC coupled architectures. Unlike what you saw in the previous slide with SkyBox, or if you've got familiarity with some of the other legacy product or even something like storage, this is going to be an AC coupled architecture. So if you've got questions on AC versus DC coupling, I'll drop another plug here. We've done a webinar on that in the past, and we're probably overdue to revisit that. AC coupling, you're going to introduce the PV power from the array on the AC bus, whereas in a DC coupled architecture, you would be introducing that wattage via DC bus, either through typically through a charge controller. So back to Sunny Boy Storage, 3 power ratings, a 3.8, a 5, and a 6. And this is really important. This is something I'm pretty excited about. Curtailment when used with the current lineup of Sunny Boy string inverters. Excuse me. The big thing about AC coupling that's I think left a lot of people on the fence over the years has been how do you properly drive or align the output from the array, so the wattage being harvested. How do you properly control that wattage and how do you get the right amount of power, I guess is the best way to say that. There's going to be instances where the system is islanded, or either intentionally or due to grid outages. So you've got nowhere for any excess power to go. How do you control the PV inverter in a fashion that makes sense? When using the Sunny Boy storage and the current Sunny Boy lineup, you get the ability to do curtailment. So the Sunny Boy storage will give commands, call it analog commands, to the Sunny Boy unit. So rather than just an on-off with a UL mandated count up, you'll be able to curtail. So in fact, the Sunny Boy storage is going to be telling the Sunny Boy, hey, I'd like 30% rated power for the indefinitely. Maybe at that point the loads have gone up, and okay, now I'll take 60% power. So you're able to really fine tune the harvest or the wattage coming out of your string inverters. Very important in designing in properly designing an AC coupled application. Other thing really exciting about Sunny Boy storage, up to 3 battery inputs and up to 3 different battery chemistries. So I suppose there's a use case for this converter as a test bed, but I think really what this feature is going to lead to is a benefit of not being locked into one storage technology over the lifetime of the system. I think it's what we've seen in the past has been when you install a system and you pick a storage solution, battery, bank of batteries, LFP, etc. You kind of pick one and you design the system around it, and that's what you've got for the life of the battery inverter, let's call it. There's certainly been instances where people have added capacity to their battery bank, but in doing so, you're typically going to want to match the chemistry. You're definitely not going to mix different cells and different batteries in the same string. You may add parallel strings. You may add another charge controller in another bank. That's all to say that can be done and that's feasible, but it's typically not best practice, and it gets you get into some really tricky corners where you might be trying to source specific batteries and ampacities from 3 to 4 years ago because customer needs have changed, loads have gone up, you've experienced some degradation on some components. With Sunny Boy storage, we don't believe that will be an issue moving forward. So again, this is not a benefit where I see people installing 3 different batteries from the get-go. It doesn't seem like that's going to be a popular move. Really, the impact here is going to be you can counsel your customers. Let's not pick good, better, best today. Let's be flexible on how we optimize good, better, best moving forward. So I can sell you battery A today in kind of the good format. In a year from now, when you've got more money or when your needs change or when utility rates go up, we can add more storage, and we're not locked into using the same chemistry, the same manufacturer, the same nameplate. The other great benefit to AC coupling is it allows you to effectively decouple, pun intended there, the PV from the storage. So in a lot of the hybrid applications, you've got not a one-size-fits-all, but you've got one product that is rated for a certain amount of DC, a certain amount of PV, a certain amount of storage, and you can adjust those ratios up or down, but you're kind of locked into a certain ballpark. With this AC coupled architecture, you can introduce really varied amounts of PV to storage. So you're not locked into the same ratio of roughly of PV to storage. You can really dial that into the application. You could, in theory, have 18 kW of PV and maybe only have one AC coupled Sunny Boy storage with a small amount of storage. So really introducing a lot of flexibility there. The other thing I'll say about Sunny Boy storage is it's ideally suited to AC coupled battery backup retrofits. That's a mouthful. What do we mean by that? Really what we're targeting here is customers who have had grid-tied installations for years now of string inverter or, geez, I suppose microinverters or even an optimized solution, and then ready for storage. This can be installed really cost effectively as a retrofit. Because it is AC coupled, you're not going to have that difficult conversation with a homeowner around, hey, let's scrap everything you've got and let's start over. You can approach this as a retrofit, as a refresh rather than as a remodel. So that's Sunny Boy storage. The other thing that is hot off the presses from last week is the auto backup unit. So this was a piece of equipment that was going to be critical for a lot of installations. This is essentially the backup unit / loads panel to be able to do backup with Sunny Boy storage. So since we started talking about this product seriously in Q2, we didn't have all the details on this this backup unit. So we could design projects with Sunny Boy storage for self-consumption and time of use, but without this backup panel, without something to selectively island the system, and without something to wire up all those backup loads, we were a little pigeonholed. So this is, again, hot off the presses. We're working on getting part numbers for this setup. What we do know about it: 200 amp bus rating, NEMA 3R rated, optional energy meter. And this is going to be really hard to see here on the slides, but we've got data sheets and things we can send you if you're interested. Your typical application here, for those of you that know, I like doing the grid on the right and the PV on the left. This is close to that. So you've got your PV array, your, of course, Sunny Boy string inverter here. They've really drawn this block diagram with this backup unit as the center of the universe, and in a lot of respects, it will be. So all of your red lines here are going to be AC wiring. Everything blue is going to be DC. So again, this backup unit is kind of the center of the universe. Optional energy meter, utility meter, grid. This backup unit is going to make the decisions on whether or not to island the system selectively. You will wire up your large, call them backup loads, through this panel. It's going to connect to your Sunny Boy storage, and then from there your battery units. So this was a really critical piece of hardware for whole home or selective backup. And again, we're pretty excited to see it come to market. Keep moving along. SMA has been busy. They've got commercial inverters as well. So not quite so new, but still working on getting all of these set up. I did want to speak to it because we think, we think these are going to be pretty popular in 2019. So a 33 kW model for small arrays and repowering legacy 600 volt systems. What does that mean? I spoke briefly at the beginning about the central inverter architectures and what we used to see in the past. We used to see central inverters, and there's air quotes there that you can't see. We used to see central inverters as small as 100 kW, and typically in the 250, 500 to 600 kW was a really popular central inverter size for a while. Those typically had like 1 or 2 MPPT channels, and you had to run string combiners and in some cases recombiners before you got to your inverter. So your string combiners might be combining 1 to 10 600 volt strings, and you'd have higher ampacity outputs. Kind of not a pyramid scheme, but essentially you'd have one central inverter. You might have one recombiner with 2 inputs to the central inverter, and then a whole array, unintended, a whole array of string combiners out in the field to parallel more and more current at the same voltage. The 33 that we're seeing here is really designed to replace those central inverters by being installed in place of some of those string combiners. So whereas out in the field you might have 1 or more 500, 600 kW central inverters, and maybe 5 to 15, 6 to 16 string combiners. You would replace basically all of that AC infrastructure and plop down these 33 kW core units and see all of the benefits of a decentralized architecture. One of the biggest drawbacks to central inverters that took a long time for people to get to was the idea around uptime and your overall harvest if there's a fault or a failure on that string inverter, on that central inverter. So if a 500 kW central inverter goes down, you've lost that whole field. Furthermore, we talked about those typically only had like 1 or 2 MPT channels. So on a ground mount where you've got everything at the same orientation and it's flat and everything's optimal, I suppose you wouldn't see a use case for multiple MPPT channels, but we know that very seldom does practice meet theory. So you see all the benefits of the core units in terms of 6 MPPT channels, 12 string inputs, lots of flexibility, really high efficiency, and you can do that in a repower application. The 62 kW model for larger arrays, this is really taking all of the promise of the core 150 kW unit that we've had for a year and change now, and just trying to squeeze a little bit more out of it. So, in basically the same footprint, call it, do some quick math in my head here, call it 25% more output with a similar footprint, similar kind of cost structure. We see this as a commercial option, but also on your smaller ground mounts as well. Smaller ground mounts, not 2 megawatts necessarily, but on a 500 to 700 kW ground mount, I think it's the perfect application for this product. The TS4-R-S, and I did the acronyms there on purpose, trying to have a little fun with my slides. That's a device that's going to eliminate the need for a gateway. It gets you module level rapid shutdown very cost effectively. Last thing on this slide here is same smart design features as the Core 150. So you see here the kind of the integrated mounting feet, places for lifting handles, small footprint. Again, a product that's not going to need racking or a ready rack or anything else built for it. It's ready to kind of plop down on a roof and secure seismically. It's a product you can use in ground mounts as well. Extremely flexible. We spoke to the footprint, spoke to 12 direct string inputs on 6 MPPT channels, really allowing people to minimize their balance of system spending. Again, you're not going to need string combiners. You're not going to need recombiners, anything like that. You can be able to bring a lot of string inputs on a lot of channels for the imperfect conditions we see on small and medium-sized commercial, where you're not going to have nice, tidy rectangular blocks of array. You're going to be fitting modules where you can to maximize the output on a small constrained roof space. Integrated AC/DC disconnects, some really good CEC weighted efficiency numbers. SunSpec enabled, so for those, I'm sure everybody's up to speed on that, but SunSpec is that power line over DC communication protocol that a number of industry players kind of came together and worked together to bring to market. People on that panel were people like Fronius, SolarEdge, et cetera. So that SunSpec open source app is what enables these TS4-R-F shutdown units to operate without another gateway, without running any kind of other DC or AC wiring out to your array. So all these communications on shutdown, reinitiate, are going to be handled over DC. Effectively, your inverter is going to send a pulse or a signal out over the DC inputs to these devices that's going to tell them, please remain operational. When the power is cut or when the initiator, in some cases, the initiator is going to be activated, that causes a loss of signal, and these units are going to open up. The last thing I'll put on here is all these units are Anexos enabled. So Anexos is a new platform that SMA is rolling out in collaboration with a couple other, call them energy service partners. And the desire here is to have a communication language shared across generation and load to manage energy more effectively. So I think we'll see a lot more on this next year, and hopefully some participation from, some of the lighting and load and appliance manufacturers in coming together with a technology that will allow people to maximize or optimize their usage over an entire facility. So really excited about what that means, and that SMA's kind of planted a stake for a more holistic approach to energy management. Keep moving along here. All right, REC and peak. So obviously here at AEE Solar, we've been huge fans and partners of REC over, most of our lifetimes in solar. And we've been really happy with the TP2 product. That's the Twin Peak 2 is the lineup of split cell multi-crystalline modules that we've carried for years now. We're currently selling the 290 TP2. It's a great product, but we've noticed that things change, efficiency improves, technology improves, and we're regularly seeing modules in the without split cell technology in the 305, 310 watt range. So REC has been working on this product for a while now. We're really excited about it. What is it? I guess in shortest summation, it's a split cell N-type mono product. Split cell. So this is something that REC really believes in strongly. Rather than having 6 strings of 10 cells that are kind of strung together north to south, a split cell technology is effectively going to take one of those, call it 6-inch diameter mono P-type or mono N-type cells, and split it in half. So this is, we're going to have to change our jargon here on 60 cell versus 72 cell, because this is actually a 120 cell module. And in having more of these, you've lowered the current at each one of these junctions and increased the voltage. We know that typically loss occurs on the current side of the equation, less so than it does on the voltage side of the equation. So in lowering the current at each one of these junctions and increasing, effectively increasing the voltage, they're lowering the overall losses on all of these junctions between cells. That's the split cell technology they've been doing for years now. The big change for this N-peak module from REC is going to be the use of N-type mono wafers instead of multi-crystalline like they have been using. So because these N-type cells are effectively negatively doped, they're not going to suffer the same light-induced degradation that you'd see from, obviously polycrystalline or even P-type mono products. That translates into a higher overall performance warranty. So, if you take a look at the data sheets, the performance warranty to the end of that 25-year period is improved over products they've marketed in the past, and improved as well over some other products you might see on the market. We're looking at a 315 and a 320 to be introduced in Q4. And ultimately, I think this is a product that's going to end up in the 325, 330 watt bins regularly. And, we'll see over the next year how that yield improves as they really dial in the production and the industrialization of this technology. The other thing that's very different about this is, if you've ever seen the backside of a 72 cell TP2 module, you've seen crossbars here. They've now introduced these on the residential products as well. So these crossbars here are not the full height of the frame. They're kind of partial height there, but they serve to add a tremendous amount of torsional stability to the module. So and this is definitely going to be an eye chart, but hopefully, if you can take anything away, it's the color coding here. So when mounted rails parallel to short side, and provided, of course, you're mounting, kind of as close to the weep holes here as possible, we see some tremendous stability in snow loading. So 7,000 pascals, 2,400 pascals uplift. We do see the trade-off here being, some some narrower tolerances on mounting locations, but even in the green zones, we're at 5,400 pascals. Another thing to call out, if you haven't used REC's products, their split cell products in the past, because I'm going to go back a slide here, because these are strung in a different fashion, not typically top of the module south and then back up again. You don't see this junction box at 12 o'clock like you would on most typical modules. You've basically got two junction boxes at the equator or at the hips of the modules, one positive, one negative. It's a short transition for any of your install crews. We've got great documentation on the wire management and wire training to offset the changes there. Look, in short, we think this is going to be a great product aimed at call it higher efficiency at a pretty good price point. And I think we'll all be surprised on the value there that's presented. I struggled with that to say value because this is, typically when we talk about value for modules, we're talking about low prices and decent performance. I think this is going to be a module with a good price and great performance. So again, that value is relative. I don't say this is a value module as a slight or as a critique. I think the ratio of performance to cost is going to be very high on this module. All right, that was the end peak. I did want to spend a few minutes talking about kind of other things we expect to see in the market here at AEE and elsewhere over the next couple months. But these are not necessarily products that I'm well equipped to speak to or have fully built out slides for. SolarEdge commercial inverters. We've had these available for a couple months now. And let me take a step back. Obviously, SolarEdge is not new to commercial inverters and optimizers, but they do have some updated offerings there in specifically 208, not specifically, but in 208 and 480 configurations. So on the 208 side, a 43.2 kilowatt unit that is in most of what I'll be talking about is a primary inverter unit with one or more secondary units. So if you've seen the images, it's it almost looks like three inverters kind of cuddled together. Some advantages to going that way in terms of you've got one secondary unit that's common across all two or three inverters. Makes it a lot easier for stocking and service strategies. Other big inverter from SolarEdge is the 100 kW unit. That is that's going to be a primary unit with two secondaries. That's going to be a 488 volt output unit. Pretty excited about that. That's going to bring to the large commercial space all of the benefit and value prop of the SolarEdge optimized solution. So, for that, we're talking about potentially big arrays, potentially big systems, but all the flexibility around optimization, multiple orientations, et cetera. Speaking of optimization, we've got some new SolarEdge optimizers announced for Q4, Q1. And it's hard to keep up because they've had a lot of new ones over the past couple months. A P850, a P800F, and I want to say there's another new one we just heard about next week. Look, we owe it to you guys to do a full-blown webinar on just kind of refreshing the large commercial landscape, and we'll probably do that. Third bullet point on here, SMA Sunday Boy refresh in Q1. So called a refresh. It's not a brand new line, but if you're a spec sheet geek like me, you notice that the Sunny Boys are currently using a nomenclature of SB-XX-40. They'll be moving to a -41. So some incremental improvements on firmware and SunSpec capability. We'll have those in Q1. Those units will be fully compatible with the TS4-R-F that we spoke about today. So getting you that module level rapid shutdown without the need of a gateway and extraneous wiring. The other thing we'll see, I believe we'll see at that point with the refresh is some RGM and GSM functionality. So RGM, revenue grade metering, GSM, the kind of cellular standard right now. So for some of the some of the loan or rebate programs that require revenue grade metering, we'll have an integrated solution for that, and we'll have wireless monitoring for those of you installers out there who are, kind of like me, reluctant to rely on a homeowner's Wi-Fi network for, monitoring and uptime validation. LG Chem Resu Type C, it's a battery we've talked about for a while now. The Type C being, CAN bus communication and not RS-485. That's what will be used with the SMA Sunny Boy storage and some of the other products we'll see in the market. Upgraded or updated battery lineup from Outback. So they've made a lot of changes to their lineup over the past year. Some new individual batteries, PLR and PLC, and they're working on high capacity footprints for those as well. And lastly, higher capacity OPZV. You'll hear some folks refer that as OPZV if they're from the Great White North. Some additions to that line in some pretty high capacity outputs from Discover, and we see a lot of interest on the tubular gel, that OPZV architecture. So pretty excited for that. Whew. That was a lot. A lot of new things coming out here. Hard to kind of distill it down into 10 to 15 slides to walk through with you guys, but a lot of great products out there. We will do our absolute best to make sure that all of our documentation, price lists, website is accurate and up to date. And I do realize the irony of talking about new products while I use my stock imagery from 2003. Yeah, really exciting stuff out there. We're going to see lots of changes on the market. We're hoping to do this without without killing off or eliminating any of the products you're currently using. Some of them are just going to be phased out though, as we see new products that target applications better, more cost effectively, et cetera. So